pass index variables to methods, we are going to solve two exercises. The first exercise, we will show you how to pass index variable as a primitive data type. In the second exercise, we will show you how to pass an index variable that is a class-based, which is an object. Let us first solve the first exercise. In this exercise, it consists of parts. In the first part, we want to create an array of integers called passcode of size entered by the user. In each element of the array, store a random number that is of exactly 8 digits. So we know how to declare an array, and if we take the size from the user, and we already know how to generate random numbers of exactly 8 digits. Let us solve this part. We will solve this exercise using only one class that has only main method, and if we need another method, we are going to define it in the same class. The name of the class is passcodes, and we have the main method inside it. Since we are going to read the size of the array from the user, so we need import java.util.scanner as well as creating an object of the scanner. First, we will ask the user about the size of the passcodes. We will display a message, system.out.print. We are going to read on the same line, how many passcodes do you want? Because we are going to generate these numbers randomly. And then we will read this number into a variable, we will call it size, read.nextInt. After reading the size from the user, we need to create an array of integers of this size. So we write int, and we are going to call it passcode, because the question says we have to call it passcode, equal new int between a bracket the size, so we write size between brackets. After we declare the array with this amount of integers size, now we need to generate random numbers of exactly 8 digits and save them into this array. So we write a for loop for integer I equals 0, I less than passcode dot length I plus plus. And this is how we process an array. If you want to visit the elements of the array one by one from left to right, then this is the way to do it by a for loop. You use a variable I as an index, starts from 0, less than passcode dot length, and you increase it by 1. So this loop, for every iteration, the value of I is changing. That means the index of the array will also change. Therefore, we will say passcode between brackets I equal to, and now here we need to write the equation for generating random numbers of exactly 8 digits. The expression that generates random numbers of exactly 8 digits uses math.random. So typecasting, and then maximum number will be 8 nines, 1, 2, 3, 4, 5, 6, 7, 8, minus the smallest 8-digit numbers is 1, and 7 zeros, 1, 2, 3, 4, 5, 6, 7, plus 1, multiplied by math.random, and after that we add the start, which is 1 and 7 zeros. So this expression will give me random numbers of exactly 8 digits. In each iteration of the for loop, an exactly 8-digit number will be generated and saved to the corresponding index variable. In the second part of the exercise, we want to write a method called isPrime that has only one integer parameter, and it returns true if the input parameter is a prime number, otherwise it returns false. Since the method returns true or false, then the return value is Boolean. We have already implemented this method in previous lessons, specifically when we were talking about dividing a problem into small subtasks, and the solution of each subtask is written in a method. And also we said that we have to write a test drive to test each method in your class to make sure that it is free of errors and really finding a solution to the subtask. Let us see the implementation of this method. Here is the implementation of the method isPrime. We have written this method when we wanted to write a method that displayed all the prime numbers between two integers given as parameters. The problem was divided into two subtasks. The first subtask was to write this method. So let us copy this method to JGrasp and try to explain how it works briefly. Now we are back to our problem. and now we need to write isPrime method into this code. Remember, we have only one main method, and we have written part A inside this main method. So if we want to call isPrime from this method main, and since main is a static, then isPrime should be also static. Before we proceed, I have found that we have a small problem with this expression. Here I forgot to put a bracket, and also for the random method, I should have also an opening bracket for the argument. So now we have the expression. Now this is the number of integers in this range multiplied by math.random method, and all together is converted into integer, and then we add it to this number. So where to put isPrime now? We will put isPrime inside the class but outside main method. So here is the definition for isPrime. In this method isPrime, it returns true if the input parameter number is a prime. Otherwise, it returns false. How it works? Let us explain it briefly. We are using a Boolean variable inside this method, which is called OK. If this Boolean variable OK is equal to true, that means that the input parameter is a prime. If it is false, that means it is not a prime. And when a number is a prime, we try to divide the number as the input parameter by own numbers from 2 until half of the number. If any of these numbers from 2 to half of the number divides the input parameters, then it is not a prime. So therefore, inside this loop, I starts from 2, it goes up to number divided by 2, which is half of the number. Any of those numbers divides number, it will change OK to false. That means it is not a prime anymore. And when we return back to the condition, since the value of OK has changed from true to false, then the loop will terminate and will go out and will return false, that the input parameter is not a prime. You know that for prime numbers, they are always positive. So if the input is given as positive number and it is less than or equal to 3, then definitely it is a prime number. So therefore, the return value of OK, which is equal to true, will be the return value of the method. That means it is a prime number. If it is not a number less than or equal to 3, then it will go inside the loop. It will start from 2 until half of the number. Any of these numbers, 1, 2, 3, until half of the number divides number, it changes the flag OK or the Boolean variable OK to false, and will return false, that the number is not a prime. Now in part A, we have declared an array with random integers. And in part B, we have defined a method that tests whether a number is a prime or not. And now in the next part, let us show you how to use the method on the random numbers in the array. In the last part, we want to print the smallest and largest prime numbers in the array created in part A, using isPrime method that is defined in part B. If there is no prime number in the array, print the message no prime number is found. Let us do that on JGrasp. To find and print the smallest and largest prime numbers in the array, first we have to check every number in the array if it is a prime or not. Then we check whether it is the smallest or largest prime numbers. So how to test every element in the array is a prime or not? Simply we do that by writing a for loop that will iterate over the array elements one by one. In every iteration, we supply the index variable of the array as input parameter to the method isPrime. If the return value is a prime, is it true? Then the input parameter is a prime. Then we go to the next step, test whether it is largest or smallest. Let us write the solution in steps. Then in every step, we'll try to discover how to change the code to get to the final result. So let us begin. First, we write the for loop that will iterate over the array numbers. It will be for integer I equal to 0, I less than passcode dot length, I plus plus. Now in each iteration, we need to check that the index variable or the number inside the array, inside the index variable is a prime or not. To do this, we use isPrime method. So we write f isPrime, and we supply the index variable of the array as input parameter to the method by writing passcode square brackets I, and then we check for the return value. If the return value of this method is true, that means the index variable passcode I is a prime number. And if it is a prime number, then we go to step number 2 and check whether this prime number is the smallest or largest prime number. After testing if the index variable is a prime or not, now we need to check inside this if statement whether it is the smallest or largest prime numbers. And to do this, we need two variables, one that represents the smallest prime number and the other one represents the largest prime number. Let us define these two variables. So here we will write integer smallest prime, and we will initialize it to 0, and we will discuss in a moment why we can initialize it to 0, and we will have largest prime number also we will initialize it to 0. Now inside this if statement, we need to check whether this prime number is the first prime number or not. Why? Because if this is the first prime number, then it will be the smallest and the largest prime number at the same time. Then for the next prime number, we are going to compare it with the smallest and largest prime number. So how to check that this is the first prime number we have or not? Here we have assigned zeros to largest and smallest. And you know that we don't have a prime number that is equal to 0. The smallest prime number is 2. So therefore, in the beginning we will check if both of these values are equal to 0, that means that this is the first prime number we have found so far, because no prime number has been assigned to any of these variables. So let us start writing the code. Here we write f smallest equal 0, smallest prime, and largest prime equal 0. So if both of them are equal to 0, that means we have not found any prime number before. So therefore, this is the first prime number, and we will assign this prime number to both of them. So we write smallest prime is equal to pass code I, and largest prime is equal to pass code I. Now what if this number is not the first prime number? Then we have to check whether it is greater than the largest and whether it is smaller than the smallest. So we write here else f, and we will check if it is passcode of I, if it is less than smallest prime, then we will replace the smallest prime by this value, which is passcode I. Otherwise, we will check if this number passcode, if it is larger than largest prime, then we will replace largest prime by this value, which is passcode I. So this is what the sequence we will follow inside this if statement. If it is a prime number, we will check whether this is the first prime number or not. If this is the first prime number, then the smallest and largest will be equal to this number. Otherwise, we will check. If it is less than the smallest, then we will replace the smallest by this number. And if it is greater than largest, then we will replace it by this number. Now, after we exit the loop, how to check that we have found a prime number or not? And if we have found the prime number, then we need to print which one is the smallest and which one is largest. Notice that if we have found at least one prime number, then the values for smallest prime and largest prime are not equal to 0 anymore. So we can check for their values after we exit the loop. And then we can check for at least one of them, by the way, because if we have only one prime number, then both of them will change. But no harm if we check for both of them. So here we will say f smallest prime equal 0 and largest prime equal 0. Then we have found no prime number, so we print system out .println, and the message that we need to print says here that no prime number is found. So I will copy the message and we will display it here, no prime number is found. Otherwise, we are going to have two prime numbers. One of them is the smallest and the other one is the largest. And if it is the unique prime number in the array, then it will be both smallest and largest. So we write system.out.println, and we will say that the smallest prime number is, and we display the smallest prime, and we will copy the message and paste it for the largest prime number is, and we print the largest prime number. This completes the implementation of our program. Now is the time to test if it has errors or not, and to test whether it run correctly or not. First, we save it, and then we compile to check if we have errors or not. So there is one error. It says that cannot find symbol. We have a spelling problem here, passcode. And let us try again, compile it. And now we don't have any errors. Let us run the program and see the result of the program. So now the program is running. It is asking for how many passcodes do you want. Let us try a small number, for example, 10 numbers. And we don't have any prime number generated in the array yet. Let us run the program for larger number. Let's say, for example, 100. Now for 100, this is the smallest prime number and this is the largest prime number. Notice that the number is large. It consists of 8 digits. So finding whether it is a prime or not, it takes considerable amount of time or computations to get the answer. Now, as you increase the number of integers, you will notice that the program will be slower. So let us go for, let's say, for example, 200. And notice now it is taking more time than if we have 100. Let's go for 500. Now it's taken more time to give the results. Now if we try 1000, notice it will take more than 3 seconds to 4 seconds. See, now it takes time to give us the result. Why? Because testing for prime numbers, it takes a lot of calculations if the number is very large.